Hello and welcome to another video by Easy Academy AI. In this particular video, we're going to be covering some of the latest releases that just came out of the DeepSeek Open Source Week. So last week, Friday, I believe that was February the 21st, I saw an announcement from DeepSeek that this week here, starting from the 24th of February, DeepSeek was going to be releasing certain open source projects to kind of explain how they achieved their results, because there were a lot of doubters that were kind of questioning how they got the results and all those things. And it is one thing for you to say something that you publish in a paper, but another one to actually show evidence that this is how it was done, and the results should match the process that you showed. So in this video, I'm going to be covering some of the things that DeepSeek has released over the past 3 days, and some of it are very, very technical. So I'm going to try to use simple words to explain it. We'll start with why they're doing this. It is very important for us to understand that, so that when you take a look at the artifacts and the open source repos, it makes sense as to why this is happening. Then we're going to talk about how they're doing this, and then some of the things we're going to explain some of these repositories and give you in layman terms what the repository is about, and sort of give you a high-level overview. If you would like me to do a deep dive for each of the repositories to explain in more technical terms what the code is doing and why I think it was created, please let me know. But I just want to give you a brief overview for each category so that it makes sense and you can follow along, because I think something big is about to come up in the near future. That's why they are doing this today. So this is the outline. We'll start with why, then we're going to go to how they're doing it, and then do a brief overview for each day, day 1, day 2, and day 3, what has been released so far. I believe the first reason is for them to silence people that have been doubting them. So a lot of competitors, a lot of people in the US here that are very patriotic and very passionate were kind of questioning how DeepSeek achieved the results they claim to have achieved, particularly in the training portion. Now for the inferencing, where you are sending a request and getting a response, that one is very easy for us to see how it is performing in terms of the quality of the results and the amount of tokens the language model is creating every second. So the result part is not really confusing, and you can't really question that part. But there were people that were saying that they were distilling the Azure, the OpenAI language model. So I believe these open source repositories and the technical explanations would try to quiet people that have been doubting their results. So I think that is one of the reasons why they did this. Another reason is it will help to explain how they were able to accomplish the training of the V3 and the R1 version of the DeepSeek model. And it will also help to explain some of the differences in speed in how the language model is able to generate the tokens at the rate that it is able to generate. I believe they're using this not just for the reasoning model, but also for the other vision and text-to-video or text-to-image models that they're working on and they are creating. So I think this is the second reason. Another reason is that this is going to help them to gain respect from the competition, because it is one thing for you to say that my language model or my product is performing very well, but when the competition and the users and the research community sees how you acquired and how you were able to get to your results, it does create a lot of respect. So this reminds me of a story where a couple of thousands of years ago, King Solomon had like people, other leaders kind of questioning how he's able to get his results. Some of them did not really believe that what they were hearing was true. And I believe the Queen of Sheba traveled to meet him. And when she actually saw how he operates and how he organized his kingdom, all those doubts were kind of like eliminated. And I think this is what it is, the same mindset and the same strategy that DeepSeek is trying to do. That is probably why you're seeing that what they're releasing is very, very technical. It is not just download the model and run it and see the results. They are explaining and they're showing you code in CUDA, code in C++, and some very small portion in Python. So this is really to gain the respect that they think that they have lost from their competition and from the research and technical community. Like I said earlier, this would help them to gain respect from the users that understand what they're releasing, and also from the research community and the open source community that are supporting products like Llama.cpp, vLLM, and Ollama. These things that they have been releasing, I think in the near future, those strategies and techniques are going to be incorporated, particularly in the inferencing side of things. Now, researchers might use their strategy to train the language model, but I think this is really going to benefit people that are using the end product, and also people that are creating the intermediary language model serving or hosting tools like Ollama, Llama.cpp, vLLM, and all these other tools that we are using to serve language models from open source repos like Hugging Face and so on. So what they're doing here really explains a lot as to how they were able to train and why the inferencing of the language models are performing at the rate it is performing. So I think down the line you're going to see that the respect is going to be there, and when they probably release their next language model, which will be better than R1 and V3, I think very small portion of the community and competition will be questioning how they got those results, because with what they're releasing now, it should explain how they were able to train and how they were able to achieve the results that they are achieving. So I think very soon we should be able to see some of these strategies and techniques being incorporated into some of the open source tools and frameworks that we're using right now. So how are they doing this? Instead of just dumping everything at once, they're doing it one day at a time over a period of 5 days. And I think this allows whoever is doing the research to be able to consume it in bite-sized chunks, which makes it much more digestible. Instead of just dumping 5 things at once, it helps you to digest it. And like I said, the competition is paying attention to this. The researchers, the open source community, the language model hosting services, they are all taking a look at this, and doing it over an extended period of time helps to maintain their attention. It also allows everyone that is paying attention to digest it much easier. So also they're showing open source repositories. So instead of just doing a press conference and running some tests with a video, they're actually showing you the exact code, which allows you to download it and replicate what they are claiming in the results. So now I'm going to go over what has been dropped in the last 3 days, and I will explain the kernels that they are releasing, some of the performance tests that they are asking you to download and run if you are interested. So the first one was the first thing that I saw was on February 21st. So even though this was done on the 20th, I did not see it until the 21st on a Friday. And this was the announcement that stated that starting this week on the 24th of February, they are going to be releasing some of these open source tools. And it is very like a no big deal kind of an announcement. Just, we're going to do this, take a look at it and let us know your feedback. And then on the 24th, on Monday, I took a look at this and I saw this. So this was the first announcement that was made, and then they dropped FlashMLA. So FlashMLA, I'm going to be going over it, but in summary, it highlights how they are able to perform computations using 16-bit floating point numbers It is slightly less precise compared to the 32-bit or maybe a higher bit value, but this allows them to be able to achieve the speed that they needed to achieve in the training phase, and also I think in the inferencing as well. And they also introduced something in the FlashMLA that allows them to, instead of using one contiguous block of key value cache, they're able to break it up into smaller chunks of 64 items at a time. So this allows them to load those chunks into memory as needed, instead of having to take a long time to load the whole thing and then just use a small portion of it. They were able to load just what is needed and what has to be referenced into the memory, and then continue to generate the tokens. So this is probably why, even though it requires slightly more calculations, the overall experience allows you to be able to generate tokens at a faster rate. So they were able to achieve that performance by using this page key value cache in their code. And this is designed for Hopper GPUs, also known as the H100 GPU from NVIDIA. So overall, that is what this announcement was about. If you take a look at the code, which we're going to take a look at right now, it is very, very, very technical. So this portion here is done in C++ and in CUDA, and this is like a very low level code. But not only have they done that, they have also created the Python version that allows you to gain access to the C++ code. So they program it as close as possible to the hardware, but then they provide a Python interface that allows you to run and execute those C++ codes to be able to reproduce the performance. Because most of the data scientists and researchers may not really have experience with C++, with C++ or CUDA, but they're able to access the Python version and run the test, and they are able to reproduce the same result. So that was from the first day. On the second day, they released another product, DeepEP. So this has to do with allowing them to be able to perform the training at a much more performant mechanism, and also perform the inferencing or decoding at a much more performant way. So this here has to do with when you have like a mixture of experts. So it controls how the experts are selected. But more important than that control, one thing that they also covered is that, imagine you have like several houses on the street or on the block, and then in each house you have an expert in each room. So what they were able to accomplish overall from this particular release is that they had a way of allowing intra-node communication. So intra-node communication has to do with how the different GPUs that are on the same machine are communicating. So imagine like different experts in the same house, but they were able to simplify and speed up the communication between those experts in the same house. Now, going from house to house, which is going from one node to another machine, to a different node, they were also able to speed up the communication. So they were using NVLink for the intra-node communication, that is between multiple GPUs on the same machine, on the same node, and then they had this RDMA network for the across the node or inter-node communication. So just imagine like different experts in the same house. So the intra-node has to do with those experts communicating with each other in the same house, but the inter-node communication has to do with the expert communicating, or the communication happening across different homes in the same street. So that is what this particular part was about. And if you also pay attention, again, they have it in C++. So this is where they are really optimizing the performance of the kernel. But They also provide a Python interface that allows you to access this and to take a look at it. So this Deep Expert Parallelism, or EP, is what they released on the second day, and then on the third day they released DeepGEMM. So this one here has to do with general matrix multiplication. So this is all the mathematics that happens that allows them to perform the training and also perform the inferencing. They had to develop this, and if you take a look at it again, you're going to see here that this one here is almost entirely in CUDA. This C++ extension that they are using to do this programming. So unlike other maybe competition that maybe they just program it in C or C++, this one actually goes down to the actual communication between the GPU and the application. So this kind of optimization also goes a long way to explain how they were able to accomplish their training in such a small amount of time using very limited resources. And they also give credit to an NVIDIA product called Cutlass and another one called Qt. So overall, this is what they have released so far from the first 3 days of this open source week. So if you have any questions, if you have any feedback, or if you want me to do a deep dive into any of these releases, whether it is the FlashMLA, whether it's the DeepEP release, or whether it's the DeepGEMM release, please put a comment on the video down below and let me know if you are interested in me doing that. I will come back again either later today or tomorrow to do another deep dive on what is done on day 4, as well as on Friday I will also cover what is released on day 5. But I think overall, like I said before, this release, this set of multi-day release that DeepSeek is doing during this open source week is mostly about allowing the competition to respect them and also getting the respect from the communities and also the open source providers that are hosting or creating tools that allows us to run all these open source language models. People like Ollama, vLLM, Llama.cpp, and others that are out there. So that's everything I wanted to cover today. Please let me know, what you think in the comments. If you like this video, please share with someone you think will benefit. Like it and subscribe to the channel. Thank you very much for your time, and I hope to see you in the next video. Thank you.